So let's try one more problem where we use the Nernst equation, where the math is just a little more complicated. Okay, so same idea, nothing new, just a little bit more math to it. So we've got this equation, zinc plus H plus gives you zinc ion plus hydrogen. So the first thing, well, we've got the voltage when the concentrations are that and the pressure is that. What's the pH in the half cell? So what they're really asking us for is what's the H plus concentration. And once we know that, we can figure out the pH. So the first thing, again, we're going to have to do is figure out what E standard is. So I write my two half reactions. Zinc goes to zinc 2 plus 2 electrons, and 2H plus 2 electrons gives me H2. Okay, and E0 for the zinc one is 0.762 volts. You may or may not remember this one is 0 volts. That's the one they're all kind of based on. So the overall reaction has a standard voltage of 0.762 volts. So if we look at our Nernst equation now, E is E0 minus 0.0257. Okay, it didn't specifically say, but we're going to go ahead and assume we're at 25 degrees Celsius. Okay, over N times the ln of Q. So Q, let's see, we've got zinc ion, so products over reactants, raised to the coefficients, times the pressure of H2, divided by, ignore the zinc, the concentration of H plus squared. So when we start filling in numbers, we've got 0.56, that was given, equals 0.762, that's what we just found out, minus 0.0257, over N, looks like N is 2 electrons are being transferred, times the ln of, let's see, oops, sorry, 0.85 times 0.988 over x squared. Okay, so negative 0.202, I just brought that to the other side, minus 0.01285, I just divided that out, times the ln of 0.8398 over x squared. Just doing all the math out here for you. So the ln of 0.8398 over x squared equals 15.7. I'm going to go to the next slide here. So I got, okay, so the last thing I wrote was the ln of 0.8398 over x squared was 15.7. So I'm going to take the inverse ln of both sides. So I get 0.8398 over x squared equals 6714933, big number. Okay, so x squared equals 1.27 times 10 to the minus 7, and x is 3.54 times 10 to the minus 4, and that's the molarity of H plus. So now I do minus the log of that, and I end up with my answer, and I end up with a pH of 3.45. So nothing really new, just another problem where the math was slightly more complicated, so you could see it at work.